Hello folks, this week we are doing experiment number 4, motion in a straight line. So for that purpose, when they come to the lab, they find these stuff under a station. They're going to find measuring tape, they find plumb bob, also masking tape. They're going to find this track that comes with this card over here, this piece of paper, and also this device which is called a motion detector or sonic render. As you see, this device has interface with computer, so every time object moves in front of this circular thing over here, this part of the device is so sensitive to motion, so it's going to detect your motion. And in this lab they try to understand motion in a straight line. For first part of the experiment, first of all, we know that they have some exercises that they need to answer these questions at home. So they answer these questions at home, they're gonna understand concept of velocity, motion in a straight line, and then we get into in-class procedure. For in-class procedure, they need to set up this device somewhere else, not on this vertical rod, somewhere else, so they can play role of the object, and basically they're gonna move in front of that sensor to understand motion with constant velocity, or when your speed goes up or when your speed goes down. So they're gonna understand this concept in this experiment. So what we usually ask them to do is to take out this device from that vertical rod and put it up somewhere else, like here on the edge of their chair. They're gonna set it up, and as you see, this part comes out, so they can set it up in a way which is in front of their motion. So this way it's gonna detect their motion. So the way I'm gonna set it up now is like this. Okay, now this sensor is detecting my motion, and every time I'm moving in front of this sensor, it has interface with computer and it's gonna detect my motion. Alright, so for first part of the experiment, it says pick one member of your lab group to serve as the object, have the person stand at 3 meters. It depends on you. Sometimes we don't have enough space in this room, so we can't really start the experiment from 3 meters marked from the ground or from the floor. So how they gonna measure this vertical distance? For that purpose, they have a plumb bob on their station. They're gonna release it from this point, the actual position of the sensor or the circular thing, and they're gonna leave a mark on the ground. So they have masking tape on their station. They take a small piece of masking tape, and right underneath tip of the plumb bob, they leave a mark on the ground. So that is basically their center of Cartesian coordinate, and they're gonna move respect to that point. For now, I'm not gonna label it on the ground, but for you, you ask your students to label it on the ground, and at the end of the experiment, ask them to remove all masking tapes from the floor. Otherwise, they lose credit. Okay. Now, for first part of the experiment, what they need to do, they go to, this is the only experiment in UPS lab that they use computer. So they go to UPS experiment folder, and they find the student motion 1, 2, 3, and cart motion. So this part is related to a student motion 1. So when they open this software, it should say that this collect button is on, so it can detect the motion, and it's distance versus time. So as the time passes, they want to see how distance changes. So they say stands approximately at 3 meters and do nothing. So they're going to detect their motion. So they're going to push on this collect button. For now, we assume that I'm located at 3 meters, so I push collect button, and they should hear that click click sound. It means that maybe we have a loose wire somewhere. So I'm going to turn on and off this device one more time, and I make sure that the green light is on. Okay, now it's connected. So one more time. For now, we suppose that I'm located at 3 meters, collect. So you hear that click click sound, and you see that my motion is a straight line. In fact, horizontal line parallel with x-axis. Means as time passes, nothing happens to my distance. But for now, we assume that I did the experiment at 3 meters. Right now, it's labeled 1.5 meter. It depends on you. If you want to reduce these lengths, it's totally fine. Next time, it says stand half meter mark and move slowly and evenly backward. This device is so sensitive, so it's going to be hard for me to push and collect button at the same time, run the experiment. but I think in your lab you'll be fine. Since you have 3 students per station, they can easily push on collect button. For now, I'm going to ask my assistant to come over here and push on that collect button. So we assume that I'm standing at ½ meter, and it's going to detect his motion as well. So you need to do it from the other side of the computer, because that sensor is, okay, yeah. So it says move backward slowly and evenly. So go ahead. Evenly and slowly. You see that we have that straight line now. Push a stop sign, please. Okay, so we're gonna disregard this part and we consider this a straight line over here. Okay, next part it says do the same thing, but this time move faster. I'm not gonna run this experiment, but we know that logically thinking, the steepness of this line comparing to previous one must be more sharper, just because object is moving faster. Next part it says finally have your object start at 3 meter and mark and walk slowly toward the sensor. So they're going to do the same thing. One partner needs to push on collect button and you move toward this sensor. And they have some theoretical question about these two motions in number 9. And they're going to answer the question, which object is moving faster? The one that has more steepness is moving faster. Next one is a student motion 2. So they close this software and they go to a student motion 2. Okay. They have this graph over here, and it says in the lab manual that they needed to make a same path on the ground and same graph over here. So each student needs to run this experiment. How? Usually I tell my students to analyze this graph before they do the experiment. So it means that as you see, for 1 second object is located at 1 meter, then it moves slowly backward until 2.5 meter. Then for 1 second again, object stops. Then it moves toward the sensor and it stops. So for this part, they need to make that path on the ground, not with masking tape. They just need to label that path, because it says on the experiment to draw that path in next page over here. So they need to know how they are supposed to move to make that graphical representation over there. So what we're gonna do, we push on collect button. Again, I'm gonna ask my assistant to push on collect button, and we assume that I'm located at 1 meter. By looking at that graph, I'm gonna be able to make same path. So go ahead. Constant, then I'm going to move backward. Unfortunately, I don't see the screen anymore. Then I'm going to move forward, and then I stop. So approximately by guessing, I was able to make same graphical representation. So this part, I think it's really fun, because they're going to tell their partner, move forward, move backward, stop for 1 second. So it's fun. They're gonna like it. But each student individually needs to run this part. Okay. When they're done, they're gonna raise their hand, and you go there and you initial your first name and last name. Usually I do it with some different color, something like purple or red, so they don't get access to your marker, because you know these kids, the UPS students, sometimes they try to get out of this lab as soon as possible. So they may use your initial over here before finishing the experiment. So make sure you do this part by yourself, and then we go to student motion number 3. For student motion number 3, what we're gonna do, we open this software, student motion. It's gonna be under same folder, but it's different path. So it's gonna be basically same procedure, but this time object is moving toward the sensor. So it's located at 3 meters. It's moving toward the sensor. Then it stops for 1 second. Then again, it's moving toward the sensor, and then it moves backward. So as long as they can make same exact path, they're gonna get full credit. When they are done with this part of the experiment, again, they raise their hand, and you go there and you initial your first name and last name. Last part of the experiment is related to motion of the card. So they take this device out and they put it back over here. Again, as we said, this sensor, that circular thing over here, circle over here, is sensitive to motion. So we purposely, we were trying to analyze motion of the card, but then we realized that the card is must be elevated. So what we did, we put this piece of paper over here. So this way, this piece of paper is going to be in front of this sensor, and it can detect motion of the object. So It says in the lab manual, if you provide initial kick for the cart, you see that it continues moving with constant velocity. In reality, that thing never happens because we have lots of friction, air resistance. Those wheels at the bottom of the car, they are not perfect wheels. So lots of friction. You see that it's not gonna even rotate one time. So what I do, I tell my students, do this part with your hand. So one time they move it toward the sensor with, let's say, constant speed, because it's written in the lab manual, constant speed. Next time it says move it faster, but they are not going to accelerate the car. They just move it faster. So object covers more distance as time passes. And then they're going to understand the plot of this motion. What does it mean when we say that the line has more stiffness? Means velocity goes up because object is capable of covering more distance in a specific time interval. So I push and collect button, and then I'm going to move these towards sensor. Okay, it seems that the sensor is not detecting motion. So what I'm going to do, maybe I need to elevate this more, and I'm going to bring this down so it's going to be more sensitive to motion. Sometimes it happens. We need to do little bit adjustment to detect the motion. So let me see if it's detecting the motion. Yes, it's detecting. Okay, so I'm going to put this object over here, and then I move it towards sensor with constant velocity. Okay, so it's going to be this line. They disregard this ripple part, and one more time, what they're going to do, they do the same thing, but with faster speed. So they see that this line, comparing to previous one, has more stiffness. As a result, object is moving faster. Since they do it with their hand, they're going to have better understanding about motion with fast speed or slow speed, or comparing these two speeds, comparing to the case that the object just stays in front of the sensor. So one time they move it with constant velocity. Next time they're going to do the same thing, but they do it faster. So they get different stiffness for these two plots. When they're done with the experiment, they tear out all these pages, cut the ruffle part, staple it, and turn it in at the end of the lab experiment. All right, good luck. See you next week.